we're back.
I wish we had a name, like, welcome to Science.
We're like the Wonder Twins.
Yeah. Okay, today we are going to talk about frozen water, or as some would call it, ice.
Ice baby.
So, we froze some things to see what would happen. But first we want to show you what would happen when it wasn't frozen.
So this is a syringe, and we took 50 milliliters of water. I know it's 50 because it is lined up with the 50. Actually, we did less than 50.
We did
to begin
25.
with. We did 25. Just kidding. So it looked more like. Sorry, I hope I didn't get you.
No, you didn't.
Okay, so just kidding. We did 25 milliliters in the graduated cylinder and see what the space looks like. And as you know from our last lesson, when things are cold, they contract. However, water is very, very special. And when it freezes, when it changes states of matter and goes from liquid to solid, it actually
expands.
So isn't that crazy? So instead of looking like 25 mils are in the syringe, this is the frozen, and we are at about 43.
That's so fast. And that expanded a lot.
It did. So have you ever frozen something, like maybe you were trying to really get a can of soda cool quickly, and you put it in the freezer, and then you forgot you put it in the freezer, and then you came back and it has made a mess, and your parents are really super happy with you? So water is in soda, and so it's going to expand. When it freezes, it puts pressure on that can. So then we have this little vial, and as you can see, kind of jiggly water level at the top. We took that, closed the cap, and guess what happened?
What?
It popped the cap.
Look at that.
And created this dome on top. And I can hear it cracking right now because it's starting to warm up. And just like a popsicle mold, you never fill all the way. You leave room for expansion. Same thing here.
So now we're going to kind of move on to two parts. This is like a two-parter. We have some water right here. Here it is. And we have some ice. And we dyed the ice blue because we want to kind of see what happens when we put the ice in the water. We're kind of going back to last times when we talked about density.
Right. And it just so happens that we have some of those props still here. Look how concentrated that blue is. It's contracted.
And there's mine way up at the top. So we're going to see what happens when we put the blue ice in the water. So there's our water. And we're going to see first
Actually, I want to give you a
that the ice is going to float. So we know right away that if the ice floats, that it is less dense than the water that is under it. It is less dense.
But what I see, I'm going to try to show you guys, is that, yes, the water is turning blue because the ice cube is letting its heat or its mass decrease. But you can see that if you look really close to the tube, or the cube rather, it's kind of like a little wavy settling down of the blue dye, and then it's being circulated even more because I'm kind of not holding this super steady. It's not one of my superpowers. But I'm seeing when the ice cube is melting that the melting parts are going straight down to the bottom. That's because they are colder than the surrounding area. We're going to do it one more time just so you can see it again. Ice cube floats. The ice cube itself is less dense,
but the cold water is more dense. So the cold water, it's very interesting, and you could try this at home. You could totally dye an ice cube blue, or any color for that matter, and put it in water and see that the cold is streaming. The ice cube doesn't want to go to that side. Streaming down to the bottom as the cold water sinks to the bottom of the cup.
So there we have again, sinking more dense because that cold from the ice cube is more dense than the water itself.
And you have one activity online today. that has to do with expansion, getting bigger, and contraction, getting smaller, of water. So you're going to work on that today as well. Bye, guys.
See you next time. Hi, everyone. So just before we were talking about how we had our syringes originally at 25 milliliters that when was in increased to 43 milliliters, and we had the vial that was a flat level, and then when we froze it, it popped the cap and met on top. Likewise, if we're working with a beaker and we know we have 80 milliliters of water in here, when we freeze it, it's no longer 80 milliliters because it expands, and we're just at about 95 milliliters here. So remember on the scale, it's balanced right now, nothing's on there, it's lined up in the center. We're going to go ahead and put the water that is in the liquid stage on one side and water that is in the solid stage on the other. I'm just going to slow down its tilt.
But Mrs. Harrington, this one says that it's 80 and this one says that it's 90.
Right, but remember, Mrs. Mosovitz, when we put the ice cube in the water last time, it floated. So things can have the same mass, but if they take up different volumes, different amounts of space, their density is different. So we know the density of water in the solid phase is less dense than water in the liquid phase because it floats. And so even though it has the same mass, it takes up the same number of grams to level the scale, the volume, the number of milliliters is different. So the density is less here because I'm taking up more space to have the same mass. This is more almost like, think about a more concentrated form of it. It's the same mass, but less space. So this is more dense than this.
It's fascinating.
It is fascinating. I'm sure there's a notebook entry for you as well.